Hello, I am Allie Hayes.
I'm Caleb.
I'm Mame,
I'm Aksa.
and this is Group 4.
We'll be focusing on Pythagoras. Hello, I am Allie Hayes, and I'll be focusing on the life of Pythagoras. Pythagoras was born in about 570 BC on the Greek island Samos. His father was a merchant, and it was said for him to have about 2 or 3 brothers. Some historians say that Pythagoras was married to a woman named Theano with a daughter named Damo and a son named Talagus. Pythagoras was well educated. He was interested in math, philosophy, astronomy, and so much more. He left Samos for Egypt to study with priests in temples. 10 years later, he was imprisoned in Babylon. He was sent to Babylon. So in about 520 BC, he was a free man and he returned to Samos. He returned home and he began a school called the Semicircle. However, his methods of teaching wasn't popular with the leaders of Samos, so he left. He settled in Cortona, Italy, and founded a religious and philosophical school where his followers lived. Pythagoras was the master of the society, and they all worked communally and discovered different theories and discoveries.
Hi, my name is Mame. Pythagoras and music. Pythagoras is credited with the discovery of the diatonic scale. He first learned the theory of music from the priests of various mysteries. One day, while thinking about the problem of harmony, he passed a brazier's shop where he saw workmen pounding out a piece of metal on an anvil. He took note of the different variances in pitch between the sounds made by large hammers and smaller work instruments. He carefully observed the tools and made note of their weights and returned to his home to construct a piece of wood that extended out from the wall of one side of his room to the other side. He attached 4 cords of light composition, size, and weight at regular intervals. He attached a 12-pound, 9-pound, 8-pound, and a 6-pound weight. These weights corresponded to the hammers he saw the braziers use. While testing out the sound of the weights, he discovered that the 1st and 4th string, when sounded together, produced the harmonic interval of the octave. He noticed that doubling the weight had the same effect as halving the string. He continued to discover the ratio between the different weights and therefore proceeded to discover the diatonic scale. The key to the harmonic ratios in music is hidden in the famous Pythagorean tetractys, or pyramid of dots. This pyramid of dots is made up of the first 4 numbers, 1, 2, 3, and 4. Their proportions reveal the intervals, the octave, the diapente, and diatessaron. The names given by the Pythagoras were derived from an estimation of the velocity and magnitude of the planetary bodies. Each of these planets, as it travels through space, was believed to contain a certain noise. Pythagoras believed the universe to be a large monochord with a chord stretching between heaven and the earth.
Hi, my name is Aksa. I'm going to be explaining the Pythagorean theorem, which you're all very familiar with. So basically, when a triangle has a 90-degree angle, as you can see right here, and there's squares on each side. So the longest side is called the hypotenuse, and it's usually referred to as C. And then the smallest is A, and the middle one is B. So the formula is A squared plus B squared equals C squared. And if you need a visual representation, it's this square squared, the middle square squared, the sum of them equals this longest, or the longest side squared. And it's basically these two put together, squared equals C squared. Okay, so here's an example of the Pythagorean theorem. Here's our right angle triangle. So here we have labeled as A5 and labeled as B12, and we're looking for the longest side, the hypotenuse, which is opposite side of the angle. The 90-degree angle is C. So we're going to plug it into our formula, A squared plus B squared equals C squared. So we plug in 5 for A, 12 for B equals C squared. We square each side. So that gives us 25 plus 144, giving us 169. And you want to square root 169. Square root each side. So C would equal 13. So the longest side is 13. And that's how you find out the other side of the triangle using the Pythagorean theorem.
Hi, my name's Caleb. I'll be talking to you today about the practical applications of the Pythagorean theorem back then and today. So the most useful application of the Pythagorean theorem is determining distance. So let's say I'm in Athens, which is right here, and I want to know how far away Troy is. Let's say that that's about here. So I don't know how far this distance is. However, I do know how far away I am from Sparta, which we can say is down here. And I know how far away Sparta is from Troy. So using the Pythagorean theorem, we can do a squared plus b squared equals c squared and find this distance right here. If this is my a, this is my b, and this is my c. So we still use this today in construction, but the most interesting aspects of the Pythagorean theorem that we use nowadays is in computer science, specifically in sorting algorithms. Sorting algorithms are ways of taking a set of data and moving that data into the right spot. We use the Pythagorean theorem to determine how long a certain algorithm is going to take. Take the bubble sort algorithm that moves data. It compares two sets of data and then switches the data if one set is in the wrong spot. Some programs with n input take n squared amount of time to run. So basically, to break it down, it's going to take one system the same amount of time to process 70 inputs as it is for two systems to process 40 inputs and 30 inputs. And that's the modern day practical application of the Pythagorean theorem. We can see 70 squared equals 40 squared plus 30 squared.